Hello everyone, welcome to our channel Wisdom ML. So in this video we'll be talking about yet another very interesting use case, that is fake news detection using deep learning technique, that is LSTM approach. So first of all we'll be talking about the problem statement, and we'll talk about what is fake news, why it is important to detect fake news, and how we can do so by using fake news dataset. And we'll train our LSTM model for that, and see how we can build a model to predict fake news by giving examples of fake news and real news into the model. See how it is predicted. So first of all, we need to understand that what is fake news. So first of all, we should know that what is fake news. So as we know that nowadays fake news are pretty common because they are mostly creeping up on. So first of all, the question is, what is fake news? So fake news is generally a falsely created. So the big question, what is fake news? So fake news is generally a false information created for deceiving users in order to damage the reputation of a person or entity. Okay, their motive is something like that, or maybe if they want to earn revenue by advertisement. Okay, so uh, and we know that due to the increased usage of social media platforms, uh, fake news are increasing at an alarming. Okay, in comparison to the days when we don't have social media platforms, that time the fake news were very low. But nowadays, in recent 2, 3, 4, 5 years, fake news are increasing really at an alarming, and it is a matter of concern. And according to Gartner research, by 2022, most people in mature economies or maybe developed economies will consume more false information than true or real information. That is the matter of concern. Uh, Fake news generally affects the offline society, affects the mind of offline society. Users who are reading those fake news, they generally uh, build up certain visualization in their mind based on the fake news, and sometimes it also hurt negatively. So, and the second important thing is that fake news directly affects the brand value of an organization. So in terms of business, if we say fake news are very harmful, because sometimes competitor companies spread fake news against their competitors so that they can bring down the users, or so bring down the user base or customer base of the competitor company. And these types, there are different types of scenario where fake news are very dangerous. So in this video, we'll be mainly talking about how we will be dealing with the fake news, and for that we will use one standard data set for that, and we'll do some pre-processing, because in that data set we have to do certain pre-processing because the data set is too noisy. And then we'll be building our LSTM model step by step. So let's move to our Jupyter notebook, that is fake news pre-processing. So we have two notebooks here. One is fake news pre-processing, and other one is the model building part. So we'll be talking about fake news detection. And before moving to actual data pre-processing, we'll also let you know that we have also written a complete write-up, technical write-up of fake news detection using deep learning LSTM approach. So if you want to see each and every step in a more detailed way, we have also shared the code, so you can see and follow the blog, and you can build the fake news classifier. Apart from that, we'll be also sharing our repo where we have all the codes which we'll be demonstrating in this video. So let me zoom a bit so that you can see better. So first of all, we'll be talking about the data set. So this is the ISOT fake news data set which we'll be using. This data set basically contains two types of articles, fake and real news. So we have two separate data sets, CSV files, fake.csv or true.csv. Let me show you. This is news data set, and we have two files. So if we open, so it is like that. There is a title, there is a text, there is a subject, and there is a date. So let me open. Yeah. So let me explain what is this data set. So this data set was collected from real world sources in case of true news. Okay. And for that, these news are actually crawled from the articles from Reuters.com. It is a very popular news website. And fake news are generally collected from unreliable websites that are actually flagged by PolitiFact. And PolitiFact is a fact-checking organization in USA, and also some fake news articles collected from Wikipedia also. So this dataset contains different types of articles based on different topics, and however, the majority of articles focused on political and world news politics. Okay. So as I told you, this dataset contains two CSV files. So both are having around 12,600 articles from Reuters.com website, and second file is fake.csv. It is also having more than 12,600 articles. So what are the actual columns? So one is the article title, which is the actual news headline, the text, which is the actual news body, type, whether it is real or fake, and subject is something for which subject it belongs to, news or politics, okay, or maybe world news, politics, okay, and the date when this article was published. So first of all, we'll be importing some very important libraries which are generally used in data pre-processing tasks. So one is NumPy, another is pandas, then collections, and then we have RE. So first of all, we'll be reading our fake.csv. So as we can see here, it has these four columns, and we have title, we have text, we have subject, and we have date. So if we see, we have different subjects in it, news and world news, polity, and all. So we'll be using only these two columns, title and text, which is the news headline and the actual news. So that's why we are dropping these unimportant columns, subject and date. So then, as you can see, the shape, it has around 23,481 records in fake.csv. Okay. So what we'll be doing is we'll first add one column to both with the name label in both fake data frame and true data frame, and we'll add label as fake so that we can properly label which data frame belongs to fake news and which belongs to true news. Now again we'll be reading true.csv. So here we have this thing, and we'll be dropping these two. So this is the drop. So after that, we have these two columns, title and text. So now you can see there is one issue in true.csv. We have the actual source also included in the text or the body of the news. And if we see that if we do classification, machine learning based classification for true and fake news, then this pattern is pretty common in almost each and every true news. So it will be treated as a pattern, but it's actually not a pattern. Okay, so that's why because we will be focusing on detecting the fake news based on the actual content of the news, not with some additional pattern. So we will be removing this thing, okay, from this text so that it will be equivalent to something like fake news. Okay. So in the next step, what we are doing is, uh, first of all, we are concatenating both the data frames, true and fake, by ignoring the index, so that both the true and fake data will be merged. Now, as you can see, we have around 44,898 records, and we have three columns. Now, if we go to so we have generated a new data frame, that is fake news.csv. So now we'll go to model building notebook. Here we are importing some important libraries. Some of them are analytics based and some of them are for plotting. And we are also using NLTK based library and Matplotlib for actual plotting. Apart from that, we are using some metrics and train test split so that we can properly evaluate our model, and train test split for properly dividing that data set for into train and test set. Next set of libraries are mostly for building LSTM model. So for building model, we are using model, and all the layers or the components which we'll be using in LSTM are also imported from keras.layers. Then another important library is the tokenizer, because we have to tokenize the text, because machine learning or deep learning model will not understand your textual data. So we have to convert it into numerical format. Again, we have to adjust our data by adding padding in the sequences, so that every record or every text should be properly sequenced or have same length before fitting into LSTM. So as we are using our Google Drive, so we have to mount our Google Drive, and there we are reading our data set. So this is our data set, as you can see. So important thing is that we have to then remove this thing that I told you in the previous notebook, because in true news we have this pattern observed. So we have to remove this up to this hyphen, and we have to retain this part. So for that we have written one regex function, okay, extract text, where we are searching that starting from the bracket start, everything which is coming before bracket till bracket end and till our last hyphen with a space will be removed. So what will be extracted? Everything which is coming after this, that is this part, this part. So this regex will do like this. And slash s is then used for spaces, because we have a space here. So for giving the space in the pattern, we are given this slash s. For giving any if you have give any special characters like this, so we have to properly encode it with the backward slash like this. Similarly, for you can see that this one, this bracket start or bracket end, also we have uh, used backward slash before that, so that it can be taken as a special character. So if there is a match, then we are using regex.group to get the matched content. Else we are returning same text. Okay. So for fake news, it will not be a match, so it will be returned as no original text. So when we apply this, we'll get this, as you can see. So what we are doing is basically we are creating another column, text processed, in which we are actually in which we have applied this stop text to get the uh, value for the true news uh, apart from the source of news. Now we have another column, as you can see, unnamed zero. This we have also removed, and next we have to uh, basically convert or transform this fake into one or true as zero. So this transformation we have done using lambda function with if else clause. So now you can see we have properly transformed our label, get our text representation. Now what we have to do, basically we have to combine our news title with the actual text news body. So that we can do by doing like this. We have to simply add the DF title with the space and then our process text. So you can see that we get our final news. So we have created another column, final news, where we are merging these two columns. So this is our final news. Now, as we know that we will be only using final news and labels for building our models, we will delete title, text, and text process. So in the next step, we are deleting these columns. And as you can see, we have only two columns, label and final news. Now, the best part is we have to do certain data cleaning. So first is we have to lowercase this text, right? So every word should be normalized and universal to the machine learning model. Okay, so it should not be treated like uh, capitalized word should not be treated differently in comparison to lowercase. So for that we are lowercasing. Then we have to remove the all the stop words because these stop words will not add any value and it only increase the number of features. So that's why we have to reduce the number of stop words. Uh, and then what we have to do is we will be only retaining alphabetic characters. No numbers, no special characters because they are not adding any value. We only want to analyze or use the contextual words which will give certain meaning to a sentence. So that's why we are first we are creating a stop list which is taken from a stop words dot words, and here we have to pass English. So this stop word is basically defined as you can see in the NLTK library. So we have to import from NLTK.corpus and then we have to import stop words. Okay. And one important thing, we have to also download the stop words. So like NLTK.download, then this will be downloaded in your root directory and this will be used when you define it. Now comes the important cleaning part, that is txt lowercasing, removing stop words. So we have used this comprehension for that. We are only containing those words which are not in the stop words, and later on we are joining it with the space. Else, what will happen? All the words will be combined with no space. So that's why we have to join all the words with the space. Next, we have to basically replace all the non-alphabetic characters from the text with the space, okay, so that nothing like special characters, numbers, or something like that should be removed from the text. So for that, we have to apply this method, clean text on final news. So now we have cleaned news, okay, with no stop words, lowercase, and no other than alphabetic character. Now the important part is setting up our configuration for building LSTM model, and for that we have to define the path of our base path basically. and where our glove embedding is stored. So in this we have used glove embedding. So embedding is something like the words, or you can see the words which have same contextual meaning. Okay. So let me go to our blog and show you this diagram. So you can see here we have two types of words, male, female, or both things. So you can see that uncle, aunt. So there is a relationship of male, female. There is some contextual relationship is there, and similarly boy, girl. So this type of relationship should be uh, maintained in the form of vectorized form. So that in the form of vectorized weight. So whenever we use those embeddings, so during any text classification task, so this type of relationship should be considered for doing the classification, so that it will be more accurate in comparison to traditional machine learning models which use count vectorizer or TF-IDF vectorizer method. Okay, because this is also keeping the contextual meaning of the words or relationship between words. So we are using basically glove embedding, having 6 billion parameters, 6 billion tokens, sorry, and 15 dimensions. So here we are setting our configuration settings, that is max sequence length 100, max vocab size 20,000, embedding dimensions 50, validation split 0.2. That means our training set will be divided internally into 80 into 20 ratio. So 20% use for validation during the model training. Batch size we have set at 32 and will be running our model for training points. So now we have to segregate our feature and labels like this. Uh, Next, we'll be loading our pre-trained word. So for that, we have to create one dictionary like this, word to vec. And here we are opening our embedding file and iterating all the lines in the file and splitting all the values using line.split. Okay. And next, what we are doing is we are basically taking first value from that values and assigning it in word, and then we are creating our vector. So what is vector? Vector is everything which is after the word. So we have a dictionary something like that, that there is a word something like this. Let's say we have a word go, and then we have a vector 1.099 something in the form of array form of. So now what's happening is basically we are taking word at in one variable and vector in as in the form of arrays we are creating. So whatever the numerical values coming for each of the word, we are converting in the form of array. And again, we are pushing both the things within the dictionary by passing word to word. For how it's happening is basically for this particular word, this vector will be mapped. So like that, we are creating dictionary. So as you can see, the length of this word to word dictionary is 4 lakh word vectors. Now we have to convert our string sentences, textual sentences into integers, because our model will only understand numeric values. So for that, we are building a tokenizer object using tokenizer, and here we are passing number of words. So number of words is nothing but the maximum vocabulary size that we have defined here, which is 20,000. So 20,000 vocabularies will be handling in this. Now we are fitting this tokenizer on our final news column, and again we are converting it into sequences. Now the best part is we have to add our sequences so that we get an n cross t matrix. Okay, n cross t matrix something how many number of records we have into the actual sequence length, that is 100. So for that, we are actually passing X, which is our final news, okay, and which is actually tokenized final news. And in here, we are also passing the maximum length, that is max sequence length. So what it will do, if the text is smaller than max sequence length, okay, so it will add additional padding in the form of zero. Or if we have a larger value, maybe more than 100 words, 100 vocabs or words, so then what it will do, it will trim up to 100 so that all the text, all the sentences have equal length of 100 vocabularies. Now next we are creating word to integer mapping. So we get our tokenizer, right? We have fitted our tokenizer on text. So now we have to create word to ID mapping. So for that we have to use tokenizer.word index. So it will give us unique tokens with their IDs. So we have 1,15,831 unique tokens. Now we have to prepare our embedding matrix, and for that we have to create number of words. So number of words is nothing but minimum of max vocabulary size or length of word to ID x plus 1. Now embedding matrix is something we have to create by using np.zeros, and in here we have to pass number of words and embedding dimensions. Okay, so it will be a matrix of number of words and embedding dimension. Embedding dimension is something, it is 50, okay, and number of words are basically minimum of these. Now we are iterating over the word to id x. Okay, word to id x is nothing but the integer on word mapping, and here we are checking one condition: if I is smaller than max vocab size, that is if the word is smaller than 100, then we are creating embedding vector with by passing word to vec dot get word. Okay. Now, if embedding vector is not present, that is, if this condition doesn't matches, then all the words which are not found in our embeddings will be considered as all zeros. Okay, because we have created np.c, right? So what we are doing is basically we are finding our club embedding words in our actual data set words or tokens or vocabularies to match. Then we assign the vector. If that it doesn't match, then we simply assign it zeros. Now we have to create embedding layer. So here we have to pass within embedding number of words, embedding dimension, weights are nothing but the embedding matrix. Input length is the maximum sequence length, that is maximum sequence length, that is 100, and we are keeping it as to enable false. So because our embeddings are already pre-trained, so our embeddings are basically pre-trained, so we are not training those embeddings. That's why it is to enable false. Now the best part is we have to build. So here we have to pass, we create an LSTM network with a single LSTM. In this we have to pass the input, and in here we have to pass the shape. So shape is nothing but max sequence length. Next, we have to pass the embedding layer, and in here we have to pass the input. Now we have to create our LSTM neurons. So for this, we have to pass. We are using basically bidirectional, and bidirectional we are passing LSTM with 15 neurons and with return sequences as 2. Now we are also doing spooling to Bendy so that we can reduce the number of features and will be only retaining the most suitable or most important features using Maximo. Similarly, as we do in CNN. Next comes the output layer where we are passing 1 because it's a binary variable. So we'll be getting only one output, 1 or 0. And that's why we are passing activation as sigmod. Now we are passing within the model both input and output, and now we are compiling our model. So for compiling, we have to pass certain things, that is loss, which is binary cross entropy, because it is a binary problem. Optimizer, we are using Adam, which performs relatively well in almost every use case. Metrics, we are using accuracy. So if we print our model summary, we can see that we have around 7,951 trainable parameters, and total parameters are something like 10,079.1. So everything is ready. Now we have to split our data set. So we have to pass this X and Y and the train test split, and we are keeping 20% for testing and rest 80% for training our model, and also passing stratify so that the balance of both the classes will be maintained, both training and testing. So that balance of both will be maintained in both training and testing. Now we are actually fitting our model by passing X train, Y train, batch size, epochs, and validation split. So as you can see, we have run this model for around 10 epochs, and you can see starting from 95% validation accuracy, it went to around 98.27. So it has done a pretty good job, this LSTM network. And if we see the accuracy history, so from around, you can say, 6 epoch, the accuracy went to more than 97%, and it also touched around 98% to 10th epoch. Similarly, validation loss stabilizes when it reaches around 10th epoch. Now comes the accuracy part. So accuracy of our training data we have calculated using model.evaluate function. And here you can see it is 99.29% for training data, and for testing it is 98.38%. So the model, you can say, is not overfitted, okay, because the difference is very small in training accuracy and testing accuracy. Now if we can see how's the prediction look like, so you can see if we pass its test within model.predict function, we are getting something like this. So these are nothing but the probability for each and every record. Okay. So 0.99 means it is fake, it is fake, it is fake, and it is true because it is closer to 0. So now we'll be plotting confusion matrix. So you can see very good performance. So around 4,637 cases it predicted correctly as fake news, whereas 4,198 true news it predicted correctly. Okay. And if we see classification report, so one, that is fake news detection or sensitivity is higher for this model, that is 99%, and for true news it is 98%. So not bad, it is very good performance by this model in just 10 epochs. Now the best part is very best. I personally feel very good, correct measure for evaluating the models, especially for binary use cases. That is ROC AUC plot. So we have plotted our ROC AUC plot, and we can see that AUC, that is area under ROC curve, is 0.99. Now, if we do some model predictions, so this is the best part because we have built our model, trained our model, we have evaluated our model. Now we will be doing some real-time news or sample news in the model, and we'll see how it behaves. So first news is actually the false news, that is fake news, and second one is the true news. Okay, we have taken from the data set. We have already previously we have separated these two news from the data set, from the original data set. One was labeled as fake, and this one is labeled as true. And here we are actually defining all our functions, and we are creating predict text function where we have to pass the list of our sentences. So as we know that we have used tokenizer, so we have to tokenize our text which we want to predict. Then we have to add sequence, these are very important steps. Then what we are doing is basically we are creating data frame where we are passing actual text, which we want to predict, and columns are nothing but the we are giving it column as and test underscore set. And now we are doing model dot predict on test text, which is sequenced text, and we get the prediction on prediction and test end as so for test end we applied all the uh, you can say clean text this one and the clean text function, and then we are also doing prediction. We are basically converting our prediction by applying lambda function. So if the value is greater than 0.5 probability, then it is fake, and if it is less than that, then it is real. So if we can see, the first one is correctly predicted as fake, whereas second one is correctly predicted as real. So this is the demonstration of fake news detection model using LSTM. All the code is available in video description. You can check our repo for this fake news detection, and you can also check our detailed blog on how to detect fake news using LSTM model in a stepwise approach. So thanks guys, thanks for watching our video. Stay tuned for more interesting videos in the upcoming week.